Welcome, everybody. Thank you for joining the webinar today. Today, we'll be talking about InfraStake, the premier IR plastic staking technology. I am Jason Dornbos, and presenting today is in the same room, if you can't tell.
Hi, I'm Casey.
And
Dave Starkey.
Can you guys hear everybody okay? Because we're using one microphone and we're all along a big, long table. So if you're struggling to hear, please let us know, and we'll try to move the microphone to a more strategic location. We've got a great presentation lined up for you today. We're going to be answering your questions throughout the whole presentation. So if you have a burning question, please drop it into the meeting chat, just like many of you are typing messages right now. That's great. Please do that throughout, and we'll do our best to answer those as we go, as opposed to just saving the questions for the end. We're going to be talking about how the InfraStake process works, how it compares to other plastic staking technologies, which applications are best suited for InfraStake, how to design your parts, and then the key equipment components of InfraStake. So first off, I'd like to know, why did you sign up for this webinar? Is there some project that you're working on, or just hoping to learn more about staking technologies? Have you used staking in the past? Go ahead and drop in the chat why you signed up for this webinar. Wanted to learn more about the tech. Thanks, Sebastian. To learn more, currently have the process in the plant and want to understand it better. Great.
Yes.
Find the best technology for my current requirement to augment the training I have had previously. Great. Awesome. Well, we hope to be able to address all of those things.
I like Mike's response.
Boss told me to. Potential application, want to understand this tech better. We provide ultrasonic sonotrodes, so to keep learning. Great. Good stuff, guys. Well, hopefully we can address all of those questions. If for some reason you feel like your questions aren't being answered, we can follow up with you afterwards and make sure to get that all taken care of. On a scale from 1 to 10, how much experience do you have with plastic staking? 1, what is plastic staking? I thought, you could only weld plastic. And all the way to 10, and if you say 10, then we'll just unmute you and turn your camera on, and then you can present, right? So go ahead and just quick, give yourself a rating. 2, 3, 1, 3, 3, 2, 2. Okay, lots of 1s, 2s, and 3s. 4. Awesome. So a quick introduction about Xtol. Xtol is a manufacturing technology company that improves the way plastic products are made, and we specialize in solving complex plastic manufacturing challenges. If you look at our logo, it's sort of a diagram and a graph. So on one side, we have plastic welding expertise, and on the other side, we have custom automation expertise. That's because we believe that the best solutions are tailored around the application. So Xtol has plastic welding expertise so that we can solve those tough plastic welding challenges. We can really dive deep into the plastic welding, plastic staking scenario, and we use our expertise to solve those challenges. Custom automation allows us to tailor the equipment that we build to your specific needs. So you don't just get some out-of-the-box machine, you can get a machine that's tailored around your specific application, and we have the plastic welding expertise to make it a high-performing solution. We have 3 main areas in which we help people. We have engineering services. This is a great way to get started learning about plastic welding. We can do prototype testing with you and help you with your joint design. It's really an extension of your engineering team. So as you embark on a new application, engage with our engineering services by contacting any of the 3 of us, and we'll get you connected to the right people to help you figure out which welding technology is going to work best and give you all kinds of great recommendations. The plastic assembly technology that we offer, you can see there's 4 main areas there. We divide these into 2 groups, welding technologies and then staking technologies. Today, we're going to be focused on InfraStake, but know that we actually have another staking technology called NanoStake that's different, but also a proprietary Xtol technology. And then lastly, of course, we sell capital equipment. So If you want a custom machine, that's something that we can provide. If you need a standard piece of equipment, that's something that we can provide. And then all of our plastic assembly technologies can be integrated into more automated lines and systems, whether that's something that you build yourself or whether that is something that you would like a different machine builder to build for you. We can help you in all those main areas. With that,
all right,
take it away.
I get the clicker?
Yes, you do.
All right. So we're actually here today to talk about InfraStake. So I think we should start with exactly what InfraStake is. So InfraStake is a type of staking that uses infrared energy to stake your part. So we're using an integrated, non-heated forming tool. We actually refer to this as a punch. And then that punch we use to mechanically retain a mating component. So we're not anticipating that the materials would weld or knit together. This is purely a mechanical joint. However, in some situations, you may see a little bit of knitting if you have similar materials. But to be truthful, that is not the goal of staking. It's a mechanical joint. InfraStake actually produces a strong, tight, and very aesthetically pleasing finished joint.
So non-aesthetic or non-hermetic.
Correct. Exactly. Better way to say it. Yeah. So within the industry, we see multiple different staking technologies: hot punch, ultrasonic, hot air, InfraStake, and NanoStake. They're completely different from one another and different from what we see in the industry. So we'll dive into that a little bit deeper. One of the unique things with InfraStake is the color matters. So whenever we're talking about infrared energy, we have to consider that the pigment or the amount of color in the material affects the efficiency, the absorption rate on how readily the energy is accepted. So the darker the material, the more efficient the technology will work. So if we look at this image here, we have these two guys in two different color shirts. If they went outside in a summer day and it was hot outside, the guy in the black shirt would actually feel that temperature more than the guy in the white shirt. It's simple physics. And we have the same thing that we have to deal with when we're dealing with InfraStake. Typically, it is not a feasibility issue. Will it work? Won't it work? It's rather a how will it affect your cycle time? So again, we don't think that because a material is light in color or maybe translucent or transparent, that InfraStake will not work. We just need to consider that when we're talking cycle times. Now, conversely, reflective material will not absorb the infrared energy. So we typically say that a reflective material is kind of a non-starter for InfraStake. It really, really disqualifies an application.
Some painted materials can be okay in some applications, but for the most part, we try to avoid those.
Yeah, for sure.
Reflective chrome, basically, absolutely no go.
Right. So let's talk a little bit about the process itself. We break this process down into 4 steps. It's pretty simple. Going left to right, the first step is we clamp the parts together using the InfraStake module. Now, when I say module, I'm going to refer to the entire tool assembly. We just call that a module internally. So step 1 in the process is we clamp your parts together. This is important. InfraStake is the only staking technology in the industry that we're aware of that the tool itself is the integrated clamping tool. It's designed to come down and hold your part together at every staking location. So that's the first step, is we bring the modules down to the work position. We actually clamp them onto your part. Step 2 is the heating cycle. You can see it's reflected by the red energy lines. When we turn the lamp on, the energy is put out radially. So it comes out side to side. That top piece is a reflector that reflects the energy down towards your part. The gold cone, we call that the concentrator. That concentrates the energy radially into your boss or your pin. So what that means is we're putting all of the energy in radially, not top down. So this technology is very forgiving towards sensitive materials. We do a demo, Sam and I have done this a million times, where we can actually stake a part in place over tissue paper without burning the tissue paper. It's that delicate and it's that precise. So we leave the module in this state. I should mention there's these blue arrows are cooling air. We use a low flow of cooling air while we're heating up the module. It seems a little counterintuitive, but as we're trying to put energy into the part, we use this low flow of cooling air to help moderate, help temper that process. We leave it in this state until your plastic becomes semi-molten. When that is molten, that's purely dependent upon your material type, color, the process settings that you're using for the module. That's all user adjustable. So we leave it in this state till your plastic is pliable. When it is pliable, then we switch to the third step, the forming step. We shut the lamp off, and then we extend that internal forming tool, that punch that we talked about earlier. You'll also notice that we have increased the blue cooling air lines from 1 arrow to 2. What we're doing here is we're switching from a low flow cooling air to a high flow cooling air. If you think about it, technically the staking process is done, and now we're just recooling, re-solidifying your part. And we leave it in this state, lights off, punch extended, high flow cooling air, until your plastic is re-solidified. This is important. We actually make sure that we're holding everything in place until that plastic is rigid and solid again. When that happens, we then retract the punch. Notice the concentrator is still clamped in position. So at this point, we're using it kind of like a stripping plate. Again, ensuring that your joint is tight and finished. At no point do we give it a chance to relax. And then the cycle's done.
Bradley asked the question, what size diameter boss should you use for NanoStake versus InfraStake? So size differences.
Great question. NanoStake we designed as a complementary technology to InfraStake. So with NanoStake, our design guidelines run up to a 5 millimeter diameter by 5 millimeter height max. And then anything larger than 5 by 5, we recommend going to InfraStake. Now, we have to be a little bit careful because that's a general design guideline. There is a little bit of room for flexibility, but I think, Bradley, for your question, probably 5 by 5 and smaller would be great for Nano. Anything larger than that, we would recommend InfraStake.
Yeah, at that point, there's a lot of overlap. So Nano could be used, for a 2 millimeter boss, so could Infra. We typically go for Infra out of the gate because of the benefits of strength. So we'll talk about kind of that strength a little bit later, but we're able to retain about 95% parent material with Infra, whereas opposed with Nano, we're typically more in the 50 to 80% range. So even though it's small, does not necessarily mean it's Nano.
Sure. Yeah. And to your point, we'll talk a little bit more about that in a few minutes. Yeah. Great question. So I want to talk, this is it's a video. Jason, I apologize. I'm not sure how to start this video on this. Do you know?
If you click next one,
I don't know. Let's click here.
There you go.
There you go.
There you go.
Okay. I'm going to talk over it because even though you can hear the cooling air running, it looks like a still picture. This is actually a video running. What we're using this to communicate is we're actually showing that this is an infrared ray tracing activity. We're not using hot air. We're actually reflecting the energy down to the part using the concentrator to concentrate it onto the material itself. It's really quick. I'm going to run it again.
Basically, we're not creating an easy bake oven.
Yeah.
Right.
We're, even though we're a few inches away from the actual module or concentrator rather, but we're still getting that IR energy driven into the part enough to soften it.
And IR energy is similar to if you're sitting in front of a campfire and you feel the warmth, you're not touching the flame. Mm-hmm. You're not, it's not the airflow of it. As soon as somebody stands in front of that fire, suddenly now you feel cold. It's the same thing here. It's radiation. It's coming down and it can travel light speed.
Sure. You're jumping ahead in my PowerPoint.
Sorry. There's a question. Could you please confirm the probe size between Nano and Infra to understand the design requirements? Oh, yes. So the module size, we'll have a slide on that, right?
We don't actually compare the two, but we will talk about size here in just a few minutes. Okay. So I want to do one more video because we just saw this video about the radiation. This is a video of the actual NanoStake, InfraStake in process. So where we saw before was a handheld operation. this is truly what it looks like in operation. So I don't know if you heard that, but if you were paying attention, you could see when the lamps shut off, you could hear a difference in pitch of both the cooling air. You heard the internal punch extend. But that's really what the process looks like. And this boss is I think it's an 8 millimeter diameter boss.
And very tall.
Yeah, and very tall. So it kind of gives you an idea of what size. Sam, do you want to talk through these couple sides?
I did want to touch on the stroke limitation, though.
Oh, sure. Go ahead.
So although there's a guideline that says we shouldn't exceed this, with NanoStake, it's a little bit softer of a restriction. We've tried to limit that to about 5 millimeters by 5 millimeters, but we've actually gone much larger than that. But with infra, there are some design limitations in the module where we have, the stroke, built-in stroke of that cylinder. There are some limitations, so we can't get larger than I think 12.7.
Okay.
So for height, there are some restrictions, and then finished diameter as well. So typically around 9.5, I think, diameter, if I remember correctly, and then 12.7 tall.
Yeah, and we have different InfraStake different size modules for different applications that offer different stroke lengths.
Yep.
So also asked, what kind of material can you use with InfraStake?
Really, we haven't ran into anything that is melt processable that we cannot stake. So as long as it's melt processable through typical injection molding or extrusion type process, we should be able to InfraStake it. We've done everything from polypropylene to PEEK and everything in between. So even high heat materials like PPA, PPS, PEEK, we have been successful doing so. As you get higher up on that temperature resistance scale into the PPAs, PPSs, and PEEKs, you start to then become a little bit size limited. So we probably would struggle a little bit with a 12 millimeter tall by 8 millimeter in diameter boss if it was made out of PEEK. But smaller bosses we should be okay with. We just want to stay away from the thermosets.
Yeah. Basically anything other than a thermoset plastic.
Yeah.
We can use InfraStake. That includes plastics that have filler. I know if everybody on the line may be aware, we're seeing more filler content in plastics than we ever have in the past. And the fillers are becoming more and more exotic. So I think it's important to state that not only can we do any plastic other than thermoset, fillers they're well included. Whether it be glass or talc or bamboo or whatever they're putting graphite in as a filler.
We actually haven't ran into really any fillers that cause us issues. We ran Teflon, talc, mica, glass, carbon fiber, pretty much a Teflon, anything you pretty much could run into. Wood, cellulose.
Well, let's talk about that. The reason is because we're not actually we're not melting the filler. We're putting the plastic in a state that filler will flow within the plastic. So understanding that basically we're not trying to melt it, we're just trying to give it a path of flow. InfraStake works really well.
Sergio has a question about the design, and we'll get to that in a few slides. We'll talk about how to design your parts.
There's a slide specifically on this, so we'll address Sergio's question then.
Okay.
So this is kind of reiterating some of the information that Casey just went over. But I like this one because it's been animated and it kind of shows a little bit more of that process. So basically, we're driving that energy radially. We're softening that plastic, and we're the polymer chains are loosening up. They're getting loosey-goosey, and we're driving that energy in softly. And so that's how we're able to retain that 95-ish parent material strength. We're not driving a lot of excessive vibration, energy, unnecessary force. It's becoming homogeneous and softened very softly. So that's how we're able to retain that strength. Then the punch comes down. Obviously, this is a cold form, and so we don't have to worry about sticky materials like nylons, polycarbs. We're softening and heating the plastic itself, and then coming down with that cold punch.
Yeah, let's park on that for just a second, because that, in my opinion, that's super important.
Yep.
Even though that punch is inside of that concentrator, it's in where all the business is happening, because it's up retracted outside of the ray tracing. The punch, the forming tool, stays cool in comparison to the plastic. So any of those other technologies that you guys have seen that have got sticking, stringing, sometimes it's called angel hair, that kind of stuff, with InfraStake, that is all, you can process that right out, because the tool stays cool, and plastic will not stick to a cold tool.
Yeah.
So another very distinct advantage.
And that punch is gold plated. And the reason we do that is so that it does not absorb that IR energy. So it stays as cool as possible. And then the high flow, obviously in between cycles, is not only cooling down the part, it's also cooling down the punch as well. But with all of that, again, that's how we're able to retain that strength. Really, we're not introducing a whole lot of stress into that plastic. So, stays strong, stays tight, and that's the key benefits of Infra. So again, we stay clamped and we hold everything in that position until everything is solidified, it's hardened back up, and it's able to be reduced and returned to its home state. So we're making sure that everything is solid, tight, staying tight before we release that. So that's why that module stays tight to the part and stays clamped. Oops, backed up a little bit too far. So within that, we also have SPC, which is another key benefit of Infra. We actually don't know of any other staking technology out there that has this level of SPC built right in. Typically, you're having to rely on operator, reviewing the parts or camera systems, but this does it right in the module. So before we even do anything with the IR energy, our punch comes down, and this is monitored by a linear potentiometer inside of the system. So the punch comes down, and it actually measures your boss height.
Before staking.
Before staking.
Yeah.
Yep. So before anything happens, every single module comes down, and it checks the each location to make sure there's no short shots, broken bosses, any deformation of the pins. So when you set up those SPC limits, it'll float inside there and alert you if there's any issues.
Yep, good part in, good part out.
Yep. Right. So if it checks out good, all locations say my boss is in the starting location where I've designated it. The lamp turns on, it does its business. Then it does its forming. And when it does the forming, it's also checking the stake height. So that's your final position, your final stake. It's also checking that, also based on those SPC limits that you've established. And what that does is it says, okay, I've driven enough energy into my part. I know my punch went down successfully. So there's a lot variation in polymer. There's potential of maybe molding your parts. Your supplier may have accidentally molded some parts out of nylon instead of propylene. That would cause the energy to be insufficient for that part. It would catch that. So as long as everything came back to that finished height where you've established this is my SPC good go, no-go limits, it'll alert you to say, I'm a good part. This is just a screenshot of what that module SPC data.
Yeah, so this is, let's talk about the screenshot just a little bit. I mean, we see the bar graph. This reads like a book, reads left to right. These are the last 30 staking locations. The red borders, those are user defined.
Yes.
So just through the touch screen, through the HMI, your machine user, whatever level you want that set at, can adjust what is a good part and a bad part, both pre-staking and post-staking.
Yep.
So it's very flexible, very, very adjustable.
Yep.
Yeah, we talked about this a few minutes ago. InfraStake is very, very gentle in comparison to like ultrasonics, the vibratory energy that's put into the part. We don't see that with Infra. So it's really, really good for delicate parts. I mean, PCB retention, that type of stuff. All of the energy is contained within inside of the tool itself, the module. What that basically means is these things don't get hot on the outside. They're not hot enough for an operator to burn themselves or anything like that. They'll get warm to the touch, but not hot.
These are typically never classified as a burn hazard.
Correct. The only thing that when we build machines, really the only thing we guard for is like pinch point. Because they don't get hot enough to hurt anybody. So they're very safe for your electronics as well. Carlos, we see that question about life cycle. We'll tackle that in just a second. So yeah, see, these are some of the benefits. We talked a little bit about strength. It is the strongest staking technology out there that we see. Everything is tight because of the clamping. It's very reliable, very repeatable. Mechanically, the modules are designed to run to a certain distance every time, and it creates a very consistent part. Safer electronics, there is no sticking, very low energy consumption. We haven't talked about this really at all. The only energy source is a 12-volt DC halogen light bulb, similar to like what's in a flashlight or in the headlight of your car. So not a tremendous amount of air. You don't have to turn heaters on and run a bunch of amperage through those. It's really low energy consumption.
In most cases with, say 10 or few boss points, you're typically in a 110.
Yeah, 110 volts, yeah. No read-through, again, because we're very precise with the ray tracing. We can protect the part that's coming in, so we don't get sync and read-through and that kind of stuff. And then we put this tamper-evident. We see a lot of customers using staking now for tamper-evident enclosures, that kind of stuff. This is a really good technology for that because you can use it at almost anything.
Yeah, you don't know if a screw's been taken in and out 5 times.
Yeah,
you can't do that with Infra. Once the head's snapped off, you're not putting it back on.
Yeah, for sure. Yep. So we offer InfraStake in 3 different standard size modules. The IS-32 there on the left, that's the flagship, by far and away the most common InfraStake module. We do also have the IS-125 in the center, and then the ISM-20 there off to the right. Difference in size, we'll talk about this a little bit. The IS-32 is 32 millimeters in diameter. The IS-125 is 1.25 inches, which is curiously close to 32 millimeters. And then the ISM-20, that is a metric, that's a 20 millimeter diameter. So you can, about 3/4 of an inch, so you can see the size. Earlier, there was a question about NanoStake versus InfraStake size. Mm-hmm. For reference, so we're looking at 32 millimeters or 20 millimeters. NanoStake is 8 millimeters. So we don't have any NanoStake slides in this presentation, but I don't want to let that question go unaddressed. 8 millimeters versus 20. Okay.
There is a question from Shiwa about can we stake, and I don't know if everybody can see that picture there, but basically, can you countersink your hole and push the material down into it? And I would say
absolutely, yes.
I would say it's probably not the strongest joint.
Correct. Can it do it? Yes, 100% for sure. We would the forming tool of that punch, rather than having a cavity in it, we would make a flat tool, and we would just squish. Is that a technical term? We'll just squish that material down in there. Now there's a little less control, but it should work.
I would say out of any other technology out there, though, Nano and Infra definitely have the best success of running pockets like this.
Yeah. So we just looked at the module sizes that are available. With those different modules come different energy sources. This is that 12-volt lamp that I just talked about. This slide's a little bit flip-flopped because that center 100-watt IS-32 lamp was the lamp that went in the module on the left last time. We should talk to the guy that put this presentation together, Jason.
That might have been me.
Anyway, the major difference is the one in the center there, the lamp holder itself is reusable, and we only change out the lamp itself. That's only for the IS-32. The IS-125 and the ISM-20, we replace the entire lamp assembly. So that little plastic disc as well as the lamp.
Which is great because typically in Infra, this is the only consumable item you will see.
Yeah.
We typically don't wear out punches. We don't wear out concentrators. if you're replacing concentrators or punches, it's typically because you've ran it into something hard.
Yeah.
So
did you just say crash?
I avoid crash.
Yeah.
So typically this, again, is the only consumable item, which is great. We've got customers that have been running these for 10 years, and they've literally only ever replaced a $12 bulb.
Yeah.
As with the ones with the built-in holders, I think those run about $60 or so.
Yeah.
But as far as consumable items in assembly line, a $12 part is a good thing.
Well, and invariably we get the question about how long do these lamps last, because we talk about this being the only consumable portion of the lamp. The manufacturer, when they build these lamps, they tell us in an ideal application they would last 2,000 hours. Now we prorate that because of the environment we're putting the lamp in. We're going to turn it on and off rapidly. We're going to pulse width power to it. Sometimes we're going to introduce machine vibration, that type of stuff. So we very confidently say that you'll get 1,000 hours of on time in service before this lamp fails. Realistically, I found in the field that 1,000 hours is very conservative.
Yeah.
I think we're closer to 1,500, 1,600 hours in
Especially if you're
typical
not
application.
pulsing.
Yeah. So if you do the math, if your cycle time is say 5 seconds, multiply that out times 1,000 hours, and that's tens of thousands, hundreds of thousands of parts before you have to replace a $12 light bulb.
Bradley asked if you can use it on the outer diameter of cylindrical surface. So Bradley, are you saying like you've got a cylinder like this water bottle and you have a boss sticking outward? Can you stake it? And if that's your question, then yes.
Yeah.
And as long as the bosses are coming out
radial.
And if that's not it, maybe you can draw us a pic.
Yeah. Is there an indication that a bulb is failing?
Yeah. We got to do a little bit of sleuth work. So we actually, the power supplies, the controllers that run things, we are monitoring the voltage draw. So we pay attention to that. So if we get an open short or something like that, if for some reason a lamp fails catastrophically, we will know, the controller will sense that particular module didn't draw the wattage it was supposed to.
It has continuity control,
Yes.
right?
Yes.
Yeah.
And then also, if a lamp is starting to degrade, which all halogen lamps will do over their life, basically what that looks like is when the lamp efficiency goes down, it ultimately will not produce enough energy within the allocated process that you've assigned, and your plastic will not become fully molten, or fully semi-molten. So what happens is when that punch tries to extend, it'll hit that hard plastic and it'll stall that punch, and then that dimension figure gets captured back in the SBC data that Sam was talking about, and you'll get a bad part because it'll say it's not fully staked. Typically, that's an indicator that that lamp may be losing energy.
I will say that a lot of our customers set a time somewhere between 500 hours and 2,000 hours. They just set a time. They say 900. We like 900 for whatever reason. Because the lamps are so inexpensive, they say at every 900-hour interval, I'm replacing all the lamps.
Proactively do it.
Proactively eliminate the bulb fade issue.
Yeah. Great questions. I'm glad that people are participating in it.
Yeah.
Makes it more fun on our side too, guys.
These are boring.
Yeah. So the next handful of slides here are basically show and tell. It's kind of some ideas of where we could use these technologies. So this is where we see InfraStake in our typical day-to-day life. Automotive industry is still our largest industry. We do see, and inside the automotive industry, we're in the car, we're under the car, we're under the hood. Anywhere on the car, typically staking is being used. Life sciences, so that's medical devices, filtration, electronics, consumer products. Everything is simple from appliances, washer, dryers, office chairs, that kind of stuff. We see a lot of staking opportunities in there.
Have you considered IR LED?
We have, and that's a kind of a convoluted answer. We've done this in the past. We've checked into it quite a bit, primarily because of size. The problem is LEDs are still cost prohibitive. Does that make sense? Yeah. They're still pretty expensive. to put in comparison to the performance and what we get out of a halogen lamp.
From what we've heard, the ones we need are still quite expensive.
Yeah, for sure. Because they're really cool because they're directional. Yeah. They don't produce visible light. I mean, there's a lot of really cool things. It doesn't financially make sense for us to switch technologies at this point. So this is actually a solenoid cap out of a Honda. If we remember way back early in the conversation, we talked about color. And if you look at this is a white part. And I said earlier, white may not be the best option for this, but this application is kind of a cool setup. A customer came to us. It was not Honda. It was somebody that was building this equipment for them. They were having problems because the other technology they were using, this is a solenoid. If the technology came down and touched the steel part, it would change the behavior of the solenoid. So they were getting a high scrap rate. And the problem is this part was so hot coming out of the tool, they couldn't check it right away. They had to let it sit for like 10 minutes before they could get an accurate measurement. So they had this conveyor of staked components that were finished but questionable. And they came to us and said, we'd like a solution. So we put InfraStake on this. We didn't think it was going to be the best solution. It's a little bit longer cycle time, 7 seconds for a really tall or small part. But when the customer came here to work in our lab to do this, immediately when the tool was gone, he was putting his multimeter on it, checking it. And there was enough benefit in that they eliminated that 30-foot conveyor of questionable width. So
all of the energy was focused into the plastic boss, and none of it got into the solenoid.
Yeah. It was a really good sell. This is an example for a door panel. This is a Honda, again, door panel, 28 bosses. This is polypropylene, has some talc in it. I show you this primarily to talk about cycle time. This is a 15-second cycle time. And what's important to understand is all of these InfraStake modules operate simultaneously. So that means we did the entire door panel in 15 seconds. This is an engine cover that we did. There's 54 bosses on this. It's kind of hard to see because of the color, the lighting on this picture. But if you look really close, you can see different size bosses, different shape bosses, and there's actually different materials in here as well. It says nylon, but there was different blends of material in here. And we were able to stake these all simultaneously. Again, an entire engine cover in less than 10 seconds. So how large, we're going to talk a little bit about design going here. How large should my boss be? And how strong is directly related to how strong do you need your joint to be? We have a whole set of design guidelines. You can actually click on this link. Are you going to make this PowerPoint available after this is done? You'll send this out? Okay, so you can get this right on our website. If you go to our website and just type in design guidelines in the search, it'll pop right up. You can download these. These will give you a bunch of information about how to design for both InfraStake and NanoStake.
We are happy to be your design guideline, though.
Yeah.
So if you don't want to read through that and, or at least use it as a tool to familiarize yourself from a 10,000 foot view, we love it when our customers come to us and say, hey, this is the challenge, or this is the part. We've done this in the past. Could we do this in the future? And we can get our design team, work with the process development center to kind of dial in that process and that design. So, feel free to use those design guidelines as a tool to help guide. But again, we actually prefer and enjoy working with our customers direct. So feel free to, call us and say, hey, this is the design we're looking at.
Yeah. And just for those that are maybe on a phone or something, Jason just put those guidelines in the chat. So they're there.
Clickable.
So as far as strength goes, we can either back into that calculation or move it forward. So you can tell us how strong you need it, and we can try to reverse calculate that. Or if you have a design already implemented, we can then say, okay, this is roughly what the strength you're going to achieve is. I will say that with InfraStake, if you have, say, 20 points on there, and you say the strength calculation says X, you can't take X times 20 and get your ultimate strength. what happens is in the field is what we see during vibration or other test failures. You're typically only as strong as 1 to 3 of those stakes. So one breaks, maybe the second breaks, or you get 2 break at the same time, and then we get what's called a zipper effect. You start to get pop, 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 pop all along the way. So, if you are very concerned about strength, work with us. Again, we're definitely here for you as that resource to try and dial you in. So as far as strength goes, really what you're trying to accomplish is stacking up material above that cross-sectional area. There is a point of diminishing return, so you can't stack 4 inches of material above it and say, I'm going to get 10 times the strength. But there is a window there where too thin, you will get the staking head to break off. So strength does come from that cross-sectional area, though. I won't bore you with the details of what these go into. But basically with the strength characteristics, and I'm going to move forward so that we can just all see these numbers on the screen as opposed to moving them one by one.
Maybe Jason put that animation in there for special.
I just like to drag things out. So here's basically the calculation. So if you come to us and say, hey, look, I'd really like to get 350 newtons of strength, we typically do apply a safety factor. I mentioned earlier that we do get about 95% parent material strength, but nobody likes to ride on that hairy edge. So we typically do apply a safety factor of about 20%. So we would take that 350 newtons, we'd multiply it by the 1.2 safety factor. We would divide that by the tensile strength of your parent material, and that will spit out a number of the cross-sectional area needed. Based on that, you'll take that and do the square root A divided by pi, and it gives you the radius, which then you multiply by 2, you get the diameter and the height. So basically, we have a calculation then, again, which will spit out that information. So you come to us with a requirement, we can back calculate into that. As far as design details, what we like to design around, these are just, again, these are on the design guidelines. We basically like to take or recommend height be between 1 to 1.5 diameter. And you can see we designated on that corner, we like radiuses. Most plastics are notch sensitive. I don't know, maybe steel is too, but plastic is notch sensitive. So if you can radius out that corner, you'll definitely get better strength. So just something to keep in mind when you're designing those parts. We can do hollow round, we can do tab. Really, we can do a lot of different shapes. This is just kind of design guidelines on, I'd say, the 80-20 rule. We see 80% either fall in round or hollow round or tab. But we do see where we've staked a lot of different shapes. We've staked four-way locators that are basically a star shape. We've staked
it's a little fingernail, like half moons, trapezoids, maybe
all kinds of different. So don't think you have to be limited to round, hollow, round, or tab. But as far as that goes, we do have those design guidelines, again, capturing 80% of what you'll run into. We do have those on our website. Again, rectangular. We also have those design guidelines built in for that. Sergio, this is for you.
Yeah, this is your question.
This
Sergio.
was you.
Yes.
So go ahead.
I was just going to say, so what our design guidelines recommend is that the through hole ideally be 10%, no bigger than 10% larger than the boss diameter. So 110% of the diameter. We do understand that you have to live in the real world, right? Our designers say it shouldn't be bigger than 10%, but we have design, we have assembly restrictions, that kind of stuff. We don't really start getting concerned until you get about 20-25% larger than the boss diameter itself with the through hole. We start to get a weaker joint the larger that through hole is. As a matter of fact, that is the largest factor of strength.
Yeah.
So we only designed, what is it, a 35% overlap?
And that's the problem. Once
yeah.
you start reaching 25, we only designed to a 35% finish staking point. So you can imagine as you get closer to that, there's not much left.
Yeah. Typically, this brings us into conversation about angles, about how do we design our part. We have a good, better, best. Well, a best, great, and poor in this situation design. And that's ideally the way we would approach these. We don't like that image there on the right. We can do it. There's a magic angle number there, and that's coming up. It's 15 degrees. Once you start getting either the bosses tipping or your InfraStake tool itself tipping, if it gets above 15 degrees from parallel of the boss, now we're thinking perpendicular to the mating part, we start to create shadows inside of the tool itself. I mean, if you remember earlier, if we were talking about that ray tracing and how we affect that part radially, you can see in this image here on the left, it's really hard to do that once we start tipping the modules. So they can be tipped for on-center spacing, for interference issues, but we say up to 15 degrees is safe. If you get above 15 degrees tipping, we're not saying no, but we're saying what we should say is let's talk about it, let's consult and see how we can fix this.
Yeah.
So the rest of this slide kind of just talked in general about spacing. We talked about the diameters of the modules. We like to see a plus minus 1 millimeter surrounding aerial for adjustability. So on your IS-32, the bottom one there, we'd like to see minimum 34 on center spacing, just so that we keep the modules in the same plane and still have a little bit of XY adjustability on the tool itself. We haven't talked about modifications yet, but we're going to. We have the ability for parts that cannot accept an InfraStake module in its regular condition. We can modify that concentrator, that gold cold on the end. This is a pretty good picture of what it looks like. So what this looks like in real world is if your part does require modification, we can do this. It's very, very common. I would say probably 30 to 40% of the projects that we do have some type of modification to them. So it's nothing to be scared of. It's very, very common for us. Then earlier, this was the water bottle question, or at least I transferred it to a water bottle question. This is orientation. InfraStake modules can be mounted in any orientation. So whether it's horizontal, vertical, top up, top down, it can be used in any of these scenarios. This is important. We get a lot of people will call us and ask us just for what the standard punch sizes are. We don't have those. Every InfraStake module, so every punch is specifically designed for the boss, the staking position that it's being used in. So we take a blank and then we design it and we machine it specifically for your unique application. That may be a dome, it may be a puck, it may be rosette, an elongated dome, whatever your part needs. But understand that every InfraStake module and punch is designed specific for your application. We go back to concentrators, these gold cones. The different modules have basic cones. Think of these as a start model. When we put this in front of our design team, they'll actually identify which concentrator is best suited for your part. And then we design the rest of the tool around this part. And you may get a concentrator that is just stock right off the shelf like this, or we may have to make a modification to it like we talked about earlier. This is what the design team works with. We then go through and we design the internal punch according to your part as well. So again, that could be a traditional dome. That second one in there, that's more like a hockey puck, like a flat top. And then you see we have an angled one. If we think back a couple slides ago, we looked at that concentrator, that module that's tipped in at a 15-degree angle. We will also machine the leading edge of the punch so that your finished part will be concentrically round. And then these are a couple other tabs, and that's actually a double aperture we did on the right. We had two staking bosses that were so close to each other, but small enough that we could just hit them both at one time with one InfraStake module. Very creative. So this talks about our processing. every one of the modules are individually controlled within a machine. So if you have a application that's got multiple InfraStake modules, they are not all forced to share the same process parameters. Every one of them is individually controlled. That gives us the ability, like if we look back at that BMW engine cover that we talked about a few minutes ago, we can process different size bosses, different shape bosses, all in the same tool movement. Now, if we happen to have machine builders on the line with us, we do set these up so that they all actuate at the same time, so that when you're building the machines, you can minimize your valve stack on that machine. Makes the machine more cost effective for you. And there's timing things and stuff that we put in there to make sure that they all actuate at the same time, even though they're controlled individually.
And this level of precision is what really sets us apart from a lot of other technologies as well. Yeah. We have customers that have historically been using different technologies like hot air cold stake or ultrasonics or plethora of other technologies out there. And when Casey or I or both of us, we've got another technology specialist, Jordan, whenever one of us come in and they're new to this technology, they're astonished how quickly we set up a process, because they're used to days, months of setup. And really, with this level of precision and accuracy, we can sometimes set up a process on 2 to 3 parts. Yeah. And it's really a game changer once you start using InfraStake if you're used to other technologies.
I don't know if we want to continue to talk about this. Some of the things that we adjust in the process is how long the lamps are left on, at what power level they're on. We do pulse width modulate these lamps to give you better control. And then we control the punch time as well, how long the punch is extended and that kind of stuff before it retracts. All of those are individually controlled. And we're getting right to the end here. If none of the standard stuff that we've talked to up until this point don't fit in your application, but InfraStake still seems to be a technology that would be preferred, we can design custom InfraStake modules for applications as well. We've done this many times throughout the year, certainly within my tenure, and they work really, really well. We'll build, the biggest one I recall is we did an InfraStake module for a GM lighting project that the single module had 32 internal punches and lamps inside of one InfraStake tool. Super cool, not cheap, not easy to engineer, but a lot of fun through that project, and we're not shy when it comes to that.
And these custom modules are with everything built in. So this is a lot of our standard components just built into one big InfraStake module. Think of it that way.
Sure.
One big module that does 8, 32, whatever it may be. Where we have some other restrictions, we actually have another custom solution even outside of this. So this, again, is fairly large. We had an application that came into us where nano wouldn't even fit. We couldn't even package nano at 8 millimeters. And there were 20 some bosses in a very, very tight location. And what we did was we actually created a custom concentrator with multiple bulbs, and we designed that for that application. But instead of dropping the InfraStake in along with the punches built in, we used a shuttle system. So we shuttled in the concentrator. We got it loosey-goosey. We shuttled that out, and the punches came down. So we really, if you have problems, please bring them to us, because in this scenario, there were multiple folks that were approached, and none of them could figure it out. And we did it from concept to production on their floor in 26 weeks, which again was something that they were really happy about. So bring the challenges, bring the easy ones. We like them all.
Yeah, yeah.
You have a standard HMI and PLC software for machine builders. Oh, you betcha.
We do. We offer, for machine builders, we offer a couple different options. We can supply you with a full turnkey controller. We call it our InfraView controller. It's got everything built in. It's got its own PLC, HMI, everything built in. It's rather pricey, but we can sell that to you. We also can go the option of providing you with the power supply controllers, and then you build the controls using the machine's existing PLC, HMI, however you want to do that. And if you choose to go that route, we will give you all of the software bundle that goes in to operate it. So all of the screens and everything, yes, would be provided for you.
And we currently have those for AB, Siemens, and now recently Mitsubishi.
Yeah.
Nice.
So that's it. I'm out of content.
Tight, strong, and safe.
Yeah.
One more slide for me here. So, okay.
No, that's not.
Okay, sorry. You want to stay on this?
No, I'm done.
Any questions?
Any questions about InfraStake before Jason talks about what we're talking about?
Start punching in more questions about InfraStake. While you're typing, I'm going to do a quick promo for our next webinar. Will be about hot plate welding for pallets, dunnage, and oversized plastic parts. So if you or somebody you know does any kind of really large assemblies that need to get hot plate welded, this webinar will be all about that. It's on May 14. You can sign up on our website. Go check that out. Share it with all your friends. Now back to this slide for Casey. Okay. Any other questions that you guys have about InfraStake? We also appreciate feedback. So how did we do? Did you guys enjoy this webinar? Did you feel like you learned something? Anything that we could have done differently that you think would go a little bit better? Drop that into the chat. Let us know. We're open to your feedback. We won't cry too much.
And occasionally through the year, we do more technical deep dives into certain technologies. We recently hosted on site an event where it was very technical on both NanoStake and InfraStake. So, and we love visitors. So if you want to come out and check us out, if you're reasonably close to Zeeland, we're happy to have you. So, reach out anytime.
Let us know if you'd like us to come to you. We have a demo kit, like I think we talked about earlier, and it's basically a single InfraStake module in a little press, and we can bring it right into your shop, and we can stake parts, and you can see the process live and hands-on. Let us know if that would be useful to you guys, and we can bring the demo kit, do a training for other people that are on your team.
If you let me,
you're the expert now. So
if you let me, I'll even buy you lunch.
Yep. Casey will buy you lunch. Can you send a recorded presentation for NanoStake? Yes, I can. There's actually a link. You can find it on our website right now, and I'll drop it into the chat. So we have a NanoStake webinar that we did. I don't remember exactly when.
Recently.
Yeah, it's not too long ago. Here, how to design for NanoStake. And then, let's do that one. Here's the how to design for NanoStake webinar. I'm going to drop this into the chat, and then you guys can.
Hey, Mike, thanks for the comment. Appreciate that. But my boss said I had to be here, guy. Actually found benefit. So thank you. Appreciate that.
Other ways to key punches and concentrators so that they are not switched between units. This has been a topic. We've tried to do this before. So you're talking about poke yoking, right? There's not an easy way to do it. We do have some customers that will key them with a color. I've actually seen customers paint the back end of the punches so that they're not the business end that's out, but the part that's retracted up inside. I've seen them done that way. But really, no, all we do is laser etch the numbers on them. But they are interchangeable because it's a basic blank that we start with. So the short answer, Ben, is no. There's not a way to key them. Cool. Thanks for joining, everybody. If you have other questions after we sign off, please feel free to reach out to us. You'll have our contact information, and we will certainly be following up with you to see if you have any additional questions or projects that you need help with. Everybody have a great day.
Yeah, that's it.
Thanks, guys.